Hi, welcome everyone. Today in this video I'm going to show you how to estimate simple regression in Python and do post-regression diagnostics. And this time I will be using VS Code to estimate the codes, and I will try to make sure that I will go through the code slowly so that you can replicate it. Okay, so here we start with relevant libraries. So I need pandas for data management and for numerics for it's NumPy, matplotlib for plotting, and cbon is also for plotting. SciPy is to do the descriptive stats, and then stat models to do regression and its diagnostics, and then sklearn is for coding a qualitative binomial variable. So I will highlight it and then press shift enter. It will load the relevant libraries in the terminal. If any one of the libraries is not available, it will say that it's not available. Then you have to uh, install that library using pip install method. Okay, so it has opened the terminal. I will do shift enter again. First time it will open the terminal, second time it will load the libraries. In my case, all of them are loaded. It has not given any error. Okay, then I will read the data file. So it is from this data file. So I will read pd and read first data method. So it has read the data file. You can see using data.head. So it has this car auto.data, this which is commonly available in SPSS datasets and data datasets. I have read this data file. Now we want to do summary stats. So first of all, we'll pick two variables and want to calculate their percentiles, then this skewness and this kurtosis. Okay, and then we go towards printing their summary stats. So when I press shift enter, it will give me mean, standard deviation, minimum, 3 percentile value positions, and maximum and skewness and kurtosis. This way, the the describe command has added mean, standard deviation, minimum, and maximum. The percentile has added these three columns, and then skewness and kurtosis. Now I want to see its normality. For that, there are two normality tests available. I have used two, but there are many more. First is the Agostino KSK test, and there is the Shapiro-Wilk test, and I run both. So in both cases, my two variables are significant in both cases. So it means they are not normal. Now I will want to do a correlation. I added one more variable here. And when I run this, it will show me a correlation matrix. So it can see it, there is a high correlation between MPG and turn and weight and turn. Okay, then we go towards pair plot. So when I run the pair plot, it will show me 2 by 2 combinations. So diagonals is the histogram and the other sides are the correlations, the scatter plots. So this way you can see patterns in the data. Next is we want to create a scatter plot within DV and IV and then add a linear fit. So when I add this, so you can see a scatter plot between a DV and IV and there is a linear fit through it. So if you want to add its circumference interval, you can add yes here. And then if you want to add the dummy variable in the regression, so I use the label encoder method to convert the foreign variable into a dummy variable. So it will print and it will show domestic equal to 0 and foreign equal to 1. Then I will do the regression. MPG is equal to weight plus foreign. So this is X. And add constant mean, it will add one column of 111 to make constant, and then this is dv, and then when I run model and then model summary, it will give me several indicators. So I will start from the top. It tells me the dv and the method and the time and number of observations and covariance method type. So it's not robust, R scale, just R, F stat, F p value, likelihood, AIC and BAC. Some extra components are here as compared to R and stata, that it gives you omnibus. This is the normality test of residuals. Then we have skewness and kurtosis value. It also tells that residuals are not normal. The Watson is more than 2. It shows that there is negative autocorrelation. Jabera also shows the non-normality. Okay, so because it's significant. So there are some extra tests. So next command, I generate residuals, and then I can generate a histogram for residual to see if it is normal or not. So when I do it, it will first of all show me the D Augustino test, and it is significant because the p-value is 6.09 raised to power minus 9, so it is less than 0.05. Then I plot the histogram for the residuals, and then you can see here is that it has very long tails, and it is skewed a little bit as compared to the ideal normal distribution shape. So it's not normal. Then we can do the heteroscedasticity test using Gross-Began test, and it is significant. So it's showing that there is heteroscedasticity. And then for omitted variable, usually we use the reset test in Stata or R, and Python it is rainbow test. So when we do the rainbow test, it is significant, showing that there is a missing, there are omitted variables. Then we go for VIF. It gives you for each independent variable, and you can see on both of the independent variables it is lower than 2, so there is no multicollinearity. Then we can see for the leverage plot, it shows us if there is any particular observation that has a huge leverage on the results of the model. So if you plot it, it will show you that there are few. So we go towards the high values, so it has high leverages here. Okay, so this shows that the observations which are numbered are actually showing the observation which has a high either high leverage or high residuals. Okay, so this shows you that it finds you the very observation which are creating the problem. Then we need to see edit variable plot. This I will show you first. The purpose of this plot is, let me get it bigger. It tells you, it plots the actual slope that is estimated on the scatter plot. So if the edit variable is not relevant or it is not appropriate, it will not be representing the data very quickly, okay, very closely. So you can see here the dots are more nearer to it as compared to this. That is why it's notable that this variable was insignificant as compared to this one in the regression. So here you can also note that if it might be non-linear, so from here you can learn that if you want to add a square variable or of that variable or not. Then it has done a reverse regression where MPG is independent and weight is dependent. It is usually done to look for if there is hint of endogeneity. So you can see that the reverse regression is significant, stat and variables are significant, so there is a hint of endogeneity, so you have to sort it out. So how to create new variables? So there's an example that you just write the name and it can generate a new variable. So it can just add a variable in the data file. So in this video what we studied was that how to properly investigate the post-regression issues in the regression analysis for a cross-section data, and we focused on how we can check for the regression assumptions. I hope you like this video and you will be able to recreate and test your models, your analysis in Python. Thank you.